Hey guys, welcome to my video on 6-3C, statistical values and box plots. Please make sure you have your calculator with you because today's going to be a heavy calculator day. And you're going to need it for the rest of the lesson. Now, to start us off, a word problem. The student scores 85, 90, 80, 90, and 100 on my 5 tests. What is the student's average in my class? Hopefully, we all know how to calculate a basic average in a class because we want to make sure that we know what grade we should be expecting, right? So we do that by adding up all the test scores and dividing it by the total number of values in the set, which in this case is 5. Now, when we do that, we get an 89. Okay, so this student with those test scores should be expecting an 89 average on their report card, assuming there's no homework or anything else averaged into the grade. So now, there is another more mathematical word for average, okay, and that is the word mean. Hopefully you've heard that word before. Okay, it's the same thing. It's the average of a set of numbers that is calculated by taking the sum of all the numbers in the set and dividing it by the total number of values, okay? But there are two other M words that we are going to use to calculate the center of our data, okay? Now, we call these calculations measures of central tendency because they each have a different perspective on the center of a data set, okay? So knowing all three of these would be important for getting a true understanding of what the numbers mean. Okay, so we have the mean. The mode, hopefully you remember this, is the value or values that appear most frequently. So we're looking for repeated. And the median is the middle number when values are listed from least to greatest. Okay, so first we're going to calculate this by hand and then talk about how to do this on the calculator. So to find the mean, right, we're going to do like we just did in the do now. Add up all the numbers. 5 plus 7 plus 5 plus 7 plus 15 plus 7 plus 2 plus 3 plus 5. And that's equal to 56. And divide it by the total number of values, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 different values. And we get a mean of 6.2 repeating, actually. So I rounded it. Okay, 6.222222. To find my mode, I look for a value that appears most frequently. So we look at our set. Are any numbers repeated? Well, I see that 5 and 7 are definitely repeated. Which one's repeated most? There are 1, 2, 3 5s and 1, 2, 3 7s. Okay, so my mode is actually going to be 5 and 7, both of them. So we would call this bimodal. Okay, because it has two modes, bi meaning two. It has 5 and 7, and that's because they repeat the same number of times. And finally, we have our median, which is our middle number. Now, in order to do this by hand, we need to list our numbers from least to greatest. So that's 2, 3, 5, 5, 5, 7, 7, 7, 15. Okay, we want to find the value that's exactly the middle. So I typically cross my numbers out in pairs. So that's 1, 2, 3, 4 pairs, leaving 5 directly in the middle. So my median is equal to 5. If I were to have an even set of numbers and there was no true middle, we would have to find the average of the middle two numbers to find the median of our set. Okay, so those are the numbers I expect you to be rather familiar with, but there are a few more calculations that we need to talk about for this data set. And that is something called quartiles, okay? Think about quarters. There are 4 quarters in a dollar. So quartiles are values that divide the data set up into 4 equal parts, okay? So our first quartile, Q1, is the median of the lower half of our data. The third quartile, also called Q3, is the median of our upper half of our data. Now, you might be asking, well, how do we know we have our upper and our lower half of data? Well, you should know it by finding the median. because Q1 and Q3 skip over that middle number of Q2. Okay, Q2 is the median, and that's the halfway point. Okay, so we've already calculated the median for this set of 5, right? That divides my data set into 2 groups on either side. My Q1 is going to be the median of my lower half. So notice I have an even set, so I have to find the average of those 2 values. So 3 plus 5 divided by 2 gives me 4. So Q1 is equal to 4. You will sometimes hear this being called the lower quartile instead of the first quartile. Those are all the same word for the Q1 value. Now we look at the upper half of our data, right? What is the median of this? Well, it's still even, right? And it's the middle of 7 and 7. Well, if you find the average of the exact same number, you get the same number. So Q3 is actually going to be equal to 7. Q2 is the 5 that we already know. Okay, now all of these numbers put together help give us the information in our 5-number summary, and we're going to add a few other values to this. Okay, our 5-number summary are the 5 values of our data set that we are going to use to create a box and whisker plot. Now, you'll see box and whisker plot in a lot of different places, but you might also see the words box plot. Okay, that's the words that the regents use. So I don't want you to get confused later on as I introduce other types of graphs. When you see the word box plot, it means the same exact thing as box and whisker. Okay, and the reason I like the word box and whisker is because it describes what it looks like. Okay, this type of graph is a graphical representation of the 5-number summary on a number line. So although this particular diagram does not have a number line, every box plot that we create from now until the end will have a number line associated with it. Okay, and how do we draw this? Well, if it's a box and whisker plot, it must have a box, it must have whiskers. So what happens? Well, our minimum value or our smallest value goes on one end, our maximum value or our greatest value goes on the other, and those are attached through whiskers to our middle box. Now, what is the box made of? Well, it's made up of our quartiles, Q1, Q2, and Q3, or our first quartile, our median, and our third quartile. Okay, so if we have these 5 numbers, we should be able to draw an appropriate box and whisker plot on an appropriate number line. So let's do that. We have all this information for this data set that we have. We already calculated Q1, median, Q3. The only thing we added was that the smallest number was 2, the maximum number is 15. Now, there are 20 or so lines on this number line, so that means I can make each line equal to 1 unit. Okay, so I could go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, the only important thing is that our graph is clear and visible and that we have an appropriate scale. Okay, meaning if we go by ones, we go by ones. If we go by twos, we go by twos. It must be consistent. Okay, so how do we draw this? Well, first I draw a point hovering above the line for each value. Our minimum, Q1, our median, Q3, and our maximum. Next, I typically draw the box, so connect these inner values, give it a belt, and then connect my whiskers to the sides of the box. Okay, so that is a box plot / box and whisker plot. And what it does, it helps us to visualize the placement of our information. So what's something interesting that we noticed? Well, hopefully you noticed that one of the whiskers is way longer than the other. It's also way longer than any part of the box itself. Okay, and that's because this data set has an interesting value. Okay, so looking back at it, are there any values in this data set that don't necessarily belong? Right? Well, we have 5, 5, 7, 2, 15. Oops, sorry. We have the number 15. 15 is not like the other numbers. It's quite a bit higher than the other numbers. And we have a vocabulary word for that, which is our outlier. An outlier is a value that lies outside, aka is much smaller or much larger than most of the other values. So whenever we're looking at a data set, if all the numbers are clustered together, such as on this, and we have one value that kind of doesn't fit in with the rest, we can call it an outlier. And now, it's not that this information is not considered anymore, because it is still a valid data point, but we can use it to help explain why the measures of central tendency are so different, right? How does an outlier affect the mean? Well, it weighs it down, right, towards the 15. It makes it higher. How does it affect our median? Well, it causes different number of values. So having outliers can make changes and explain changes in our measures of central tendency, okay? So that's most of the information about measures of central tendency. The other type of information that we need to pay attention to is something called the measures of spread. Okay, the measures of spread are basically the different measurements we have that tell us how spread out my data is. Okay, so we're still working with the same number. One measure of spread you should be familiar with is the range, which is the maximum minus the minimum value, the biggest minus the smallest. Okay, so if we wanted to find the range of this, we would take 15 and subtract 2 to get 13. Now, what does that mean? What is this range of 13? Well, that means all of my values are found within 13 values. Okay, it doesn't tell me where specifically it's found, but it's all found within 13 values. Now, considering data information, that can either be a small amount or a big amount depending on what you're looking at. But that's what it says. Another type of range we should be familiar with is something called the interquartile range, or the IQR. Now, the interquartile range is the range of my upper and lower quartiles. So 7 minus 4. Okay, so now what does that tell me? Well, the interquartile range tells me that the middle of my data set, right, all the values hovering around my median, are found within 3 values. 3 values, okay? As opposed to the 13 total values that this data set is spread out upon. Okay, and that should make sense because that outlier of 15 makes the range a lot higher than the interquartile range. Okay, so these give us different perspectives of how our information is spread out. So now the moment you've all been waiting for, how can we do this on our calculator? Because this is the fastest, most efficient way to do these problems. Okay, now remember everything we pressed for our linear regression / line of best fit. We are going to do that for these values. Now, you will be encouraged to use your calculator for these basic calculations. Okay, so if I ever asked you for the mean, median, range, you're going to be expected to find your values with your calculator and then be able to explain what you find. So you're going to press Stat Edit to get into the table. Enter all your values into L1, and that's because we only have one data set. Okay. Then you're going to press Stat Calc, right? Move over to Calc and choose the option 1 var stats. Okay, 1 variable statistics. This is going to tell us most of the information that we need to know. So now I'm going to zoom in on these boxes because this is what you should see on your calculator. Now, I didn't plug in the numbers that we used, but this is what it looks like. So the first line is the first thing you should be paying attention to. This line right here represents my mean of my data, okay? X bar is a symbol that you should be familiar with as our mean. It should be something that you use to denote the mean, okay? What else is found in this information? Well, if you scroll down a little bit, right, you should see min X, which is our minimum, Q1, median, Q3, and max. So our 5-number summary is found all the way at the bottom of this list, okay? Now, what don't you see on this list? Well, we don't see our range, okay, but we do have the values that we can use to calculate it. We don't see our interquartile range, but again, we can use these values to calculate it. And we don't see our mode, Okay, that's something you might need to find on your own. So other than that, everything else is found. Now there's something else on this screen that is going to be important to us, and that's called the standard deviation. Now I have these here. These are the two calculations of the standard deviation. Now one is called our sample standard deviation, one is called our population standard deviation. They should be very similar to each other, just slightly different because they're referencing different populations. Okay, the one that we use in Algebra 1 is SX. Okay, so now what is the standard deviation? Well, it is another measure of spread. It's another measure of how spread out my data is. So specifically, it is a measure of how far the numbers in the data set deviate, right, deviation, from the mean. How different are they from the mean? Are they really spread out from the mean? Are they really closely packed to the mean? Okay, you'll sometimes see lowercase sigma as a symbol for this, but again, we're going to be using the SX in Algebra 1, which is our sample standard deviation. Okay, so now what does this number tell me? Well, a high standard deviation, a big number, tells me that my numbers are very spread out from the mean. Okay, on average, the distance away from the mean is big. A low SX, or a low standard deviation, tells me that my numbers are more closely packed together towards the mean. Okay, they're not that far apart from the mean. Okay, so I challenge you to use your calculator and plug in the values that we have been working with into your calculator. Okay, see what you get. Okay, you should get X bar is equal to 6.2222, etc. You should see SX, my standard deviation, is 3.734 ... You should see my min X is equal to 2. My Q1, is equal to 4. My median is equal to 5. My Q3 is equal to 7. And my max is equal to 15. From here, you should be able to draw a box and whisker plot for it. You should be able to calculate your range.